All right, the first set of problems deal with this graph. So let's go ahead. I went ahead and drew the graph out of the text that I have. Okay, so let's take a look. This is f of x. And they say, let's take, number 9 says, find the limit as x approaches -3 from the left of f of x. Okay, so -3, that's this x value. Okay, and what's happening as f of x comes there from the left? We're going up towards infinity. Okay, number 10, the next question is the limit as x approaches -3 from the right of f of x. Okay, so as we're coming from the right, we're coming along this side. It's going to equal 1. Okay, so then the limit as x approaches -3, there's no value we can attach to it. We can't even attach an infinite value to it. Okay, let's do a couple more with this graph. Let's do number 11. And it states the limit as x approaches 0 from the left of f of x. So as x approaches 0 from the left, so that means we're coming along to this point, or that line, we're going along this way. So it's going to be negative infinity. And you can guess the next one. What's the limit as x approaches 0 from the right of f of x? Okay, as x approaches 0 from the right, we're coming along this path down to negative infinity. Okay. All right, let's continue. Number 18. This goes away from this graph. So number 18 gives us, let me adjust my desk here, my workspace, and we're going to take the limit as x approaches 3 from the left, 2x over x minus 3. Okay, so we could try to graph this. Okay, you could graph this if you like, but it may be a little bit difficult. I can graph it. I know how to graph it. I'm not trying to avoid graphing it, but I want to teach you how to do it without having to graph it. Okay, so what I'm going to do, I'm going to put that 3 in. Okay, but anywhere that I see that it's 0, I'm going to put whether it's to the left of 0 or to the right of 0. Okay, so this is very informal. Okay, so in the numerator we're going to get 6, no problem, but in the denominator we're going to get 0. Now, is it going to be 0 from the left or 0 from the right? Well, we're going to 3 from the left, so things like 2.9, 2.99, 2.9999999. Okay, so the x minus 3 is going to be a small negative number. Okay, so now we have 6, which is positive. Okay, it doesn't matter. I mean, it's 5.999999999999999 repeating, right? Or something like that. Not repeating forever, because if it repeats forever, it's just 6. Okay, over a small negative number. So a positive number over a negative number is going to give you a negative, and in this case, infinity. Okay, let's try another one. Let's try 22. Okay, limit as x approaches 8 from the right, x over 8 minus x. Okay, this one's a little bit trickier because of the 8 minus x. Okay, so let's just think about this for a second. Okay, so we're going to get, well, 8 in the numerator is fine. Now, in the denominator, 8 from the right. So that means we're going to have things like 8.1, 8.01, 8.001. 8 minus 8.0, let's say 8 minus 8.1, is that going to be positive or negative? Good, it is negative. 8 minus 8.1 is going to be negative 0.1, right? So this is going to be 0 with a negative. So just because this one has a positive doesn't mean that 0 is going to be a negative. You have to be a little careful, okay? And that is, again, going to be negative infinity. Okay, let's try another one. Let's try 26. 26 gives us the limit as x approaches 1 from the right, let's do it like that, 1 from the right, okay, of 2x plus 1 over x minus 1 squared. Okay, so the numerator is going to be, numerator is again pretty easy. It's not 0, it's 2 plus 1, that's 3. If you want to put a little plus on it, it's not going to hurt anything, but you don't need it. Okay, x minus 1 squared. Okay, well, the square means it's always going to be positive, right? Okay, it would be a little better if it was 1 minus x, then you'd have to switch it. But x minus 1 squared, because you're squaring it, so it's 0 plus squared, if you like. That's positive infinity. Okay. All right, I'll see you guys in the next page of problems.